Your brain's energy levels aren't as simple as charging a battery. While you sleep, adenosine, a biochemical byproduct of cellular activity, accumulates. In 2006, researchers at Harvard found adenosine levels rise 20% in the basal forebrain during wakefulness, driving sleep pressure. This challenges the myth that sleep should instantly refresh you. Instead, your energy is partially replenished through ATP synthesis, a complex intracellular process. Adenosine clearance doesn't happen until certain sleep stages, particularly during slow-wave sleep. If interrupted, this can leave you feeling groggy. Contrary to common belief, it's not just the amount of sleep, but the quality of these stages that matter. Your brain is a master of time, governed by circadian rhythms. These internal clocks synchronize with environmental cues, like light and temperature. The suprachiasmatic nucleus in your hypothalamus precisely regulates this 24-hour cycle. Yet, artificial light can trick your brain, delaying melatonin release, crucial for restful sleep. In 2001, a study in the Journal of Clinical Endocrinology and Metabolism showed that exposure to light at night suppresses melatonin by up to 40%. This disruption can leave you waking up exhausted, as melatonin plays a pivotal role in entering restorative sleep phases. It's the timing, not just the duration, that counts. During sleep, your brain undergoes glymphatic clearance, flushing out metabolic waste. Discovered in 2012 by researchers at the University of Rochester, this system increases 60% in efficiency during sleep. It's like a nighttime housekeeping service for your neurons. Misunderstanding this leads people to overlook how critical uninterrupted sleep is for cognitive clarity. Disrupted sleep impedes this clearance, leaving toxins like beta amyloid to accumulate, linked to neurological decline. Your brain needs uninterrupted time, especially during slow-wave sleep, to perform this essential detoxification. It's more than just feeling refreshed. It's about maintaining brain health. An overlooked aspect of sleep is cortisol's role in energy regulation. Contrary to popular belief, cortisol isn't just a stress hormone. Your cortisol levels peak in the morning, part of the cortisol awakening response, preparing your brain for the day. A study by the University of Westminster in 2009 found that this peak increases alertness by up to 50%. Misaligned sleep can disrupt this cycle, leaving you fatigued despite sufficient hours. Your body's timing, not just your alarm clock, dictates this rhythm. Understanding cortisol cycles helps explain why you might wake up tired despite sleeping through the night. The architecture of sleep is far more intricate than a simple deep-to-light cycle. Sleep consists of multiple stages, each vital for different brain functions. REM sleep is particularly crucial for memory consolidation and emotional regulation. A 2018 study in the journal Science showed that REM sleep facilitates synaptic plasticity, the foundation of learning. Disruptions in REM, often from irregular sleep schedules, can impair cognitive processing. Each stage supports different aspects of brain health, from memory to mood balance. It's not just about how long you sleep, but how well you cycle through these stages. Inside your neurons, adenosine binds to A1 receptors, inhibiting wake-promoting neurotransmitters like dopamine. This action is reversible during sleep, as adenosine is metabolized. A study from Stanford University in 2010 revealed that this binding regulates sleep pressure by modulating neuronal activity. The process peaks during slow-wave sleep when adenosine levels decrease by 40%. The misconception that all sleep stages are equal ignores this precise cellular mechanism. By understanding adenosine's role, you appreciate why uninterrupted slow-wave sleep is essential for waking up energized. It's not merely about closing your eyes, it's about cellular recovery. Glymphatic clearance operates via aquaporin 4 channels, which facilitate fluid exchange between cerebrospinal fluid and interstitial fluid. This system is 90% more active during sleep, according to a 2013 study in Science Translational Medicine. These channels open as neurons shrink, allowing waste to be efficiently flushed out. Without this, metabolic byproducts accumulate, contributing to cognitive fog. The efficiency of glymphatic clearance underscores the necessity of deep sleep for brain detoxification. It's a mechanism that's both vital and often overlooked, emphasizing why interrupted sleep leaves you feeling sluggish. This insight connects the dots between sleep quality and mental acuity. Circadian oscillator genes, like clock and BMAL1, govern your body's timing. These genes regulate transcriptional feedback loops that control hormonal cycles. Disruptions, such as irregular sleep schedules, can desynchronize these loops, leading to fatigue. A 2017 study in the journal Cell found that misaligned circadian rhythms can lead to a 30% decrease in metabolic efficiency. These genes aren't just passive timers, they actively synchronize bodily functions with the environment. Understanding this genetic orchestration helps explain why waking at odd hours leaves you drained. It's a sophisticated internal clockwork, not just a simple day-night cycle. Orexin, also known as hypocretin, is a neuropeptide that regulates wakefulness and appetite. It activates neurons in the lateral hypothalamus, maintaining wakefulness. A deficiency, as seen in narcolepsy, leads to excessive sleepiness. According to a 2019 study in Nature Communications, orexin signaling is crucial for sustaining alertness. This mechanism highlights why mere sleep duration doesn't guarantee wakefulness. Orexin's role is to integrate metabolic and circadian signals, ensuring you're awake and alert. It's not just about how long you sleep, it's about how your brain maintains wakefulness through these intricate signals. REM sleep is a stage where memories are consolidated and emotional experiences are processed. During this stage, the brain undergoes synaptic pruning, strengthening important connections. A 2020 study in Nature Neuroscience showed that REM sleep enhances synaptic plasticity by 25%. This stage is vital for cognitive resilience and emotional stability. Interruptions in REM sleep can lead to impaired memory and emotional dysregulation. It's not merely about dreaming. REM is a critical phase for mental health. Understanding this reveals why REM disruption makes you feel drained, even after a full night's sleep. Your brain's nightly work is far more complex than it appears. Chronic sleep debt accumulates like financial debt, with compounding interest on fatigue. Studies at the University of Pennsylvania in 2003 showed that even partial sleep deprivation, like 6 hours per night for 2 weeks, impairs cognitive performance equivalently to staying awake for 48 hours. This highlights the severe long-term impact of consistent sleep loss. Unlike acute deprivation, where recovery sleep can partly restore function, chronic sleep debt requires sustained changes. It's not just about catching up on weekends. Your brain's neuroplasticity and cognitive abilities degrade over time. Understanding this cumulative effect underscores the importance of regular, uninterrupted sleep cycles. Sleep tracking apps often provide incomplete insights. Polysomnography, the gold standard in sleep studies, captures detailed brain wave patterns, oxygen levels, and heart rates, data that consumer apps can't fully measure. A 2021 study in the Journal of Clinical Sleep Medicine found that apps underestimated sleep stages by up to 30%. This discrepancy can lead to misconceptions about your sleep health. Apps might suggest restful sleep, but without polysomnography's detailed data, critical disruptions go unnoticed. Thus, while apps are convenient, they can't replace comprehensive sleep assessments. Understanding this limitation helps refocus on scientifically backed methods for evaluating sleep quality. The wellness industry often promotes quick fixes like supplements and gadgets for better sleep. However, peer-reviewed literature emphasizes behavioral changes and environment adjustments. A 2018 meta-analysis in sleep medicine reviews highlighted that cognitive behavioral therapy for insomnia, CBTI, improved sleep efficiency by 20%, far exceeding commercial sleep aids. Misleading claims distract from evidence-based interventions. While gadgets may offer convenience, they often lack rigorous scientific validation. Peer-reviewed research provides a more reliable guide to understanding sleep mechanisms and improving sleep quality. This distinction is crucial for making informed choices about your sleep health. Your body's internal clock can be reset with consistent sleep patterns, yet many ignore this potent tool. A 2015 study from the University of Surrey showed that regular sleep schedules align internal circadian rhythms, enhancing sleep quality by 25%. Ignoring this leads to a constant state of misalignment, akin to perpetual jet lag. This misalignment impacts hormonal cycles, metabolic processes, and cognitive function. Aligning your schedule with natural circadian cues can significantly improve how refreshed you feel upon waking. It's not merely about the number of sleep hours, but when and how those hours fit into your biological clock. Reconsider how you define rest. A 2022 study in neuropsychobiology discovered that perceived sleep satisfaction, independent of actual sleep duration, impacts mood and alertness by 35%. This suggests subjective sleep quality, shaped by expectations and perceptions, plays a crucial role in how rested you feel. It's a psychological dimension, often overshadowed by physiological metrics. Perception intertwines with biology, influencing post-sleep energy levels. This reframing challenges the notion that more sleep is always better, highlighting the complex interplay between mind and body. Your brain interprets rest not just by hours, but by how those hours align with your expectations.